This is Algebra 2, Lesson 6.1, Properties of Exponents. So, we are going to go over some exponent rules or shortcuts to help you simplify exponent expressions. The first one is the product property. So, when you have a base to a power times the same base to a power, could be the same or a different one, the shortcut is that you would add these together. Okay, so your base stays the same, and then you're going to add your exponents together. And I'm going to show you the long way and the short way of why that works out. So if I have 2 to the third, that's the same as 2 times 2 times 2. Times 2 to the fourth is 1, 2, 3, 4. So if you notice here, I just have 3 2's and I have 4 2's, so altogether that's the same as 7 2's. So rather than writing them out the expanded way, I could just say 3 plus 4 is 7. My 2 stays 2, and I add my exponents together. Power of a power is a to the power of m, quantity to the power of n. The shortcut is that you would multiply your exponents together. And again, in expanded form, 2 to the third is 2 times 2 times 2. And that whole thing to the fourth means I have that group of 3 4 times. So altogether, if I was to count those up, there are just 12 2's there. So shortcut, 2 to the 3 to the 4, we multiply 3 times 4 to get 12, the base stays the same. Power of a product is kind of like the distributive property, where everything inside your parentheses gets the exponent, not just the last thing. So in expanded form, 7x to the 3 means I have 3 groups of 7x. But if you notice, that means I have 3 7's and I have 3 x's. So I could simplify that with 7 to the third and x to the third. The quotient property says a to the m divided by a to the n, and that would be equal to a to the m minus n. Your base stays the same. Whatever your powers are gets subtracted. So I'm going to try to write this one out in expanded form as well. 5 to the 6th means I have 6 5's. 1, 2, 3, 4, 5, 6. And then in my denominator, I have 2 5's. Now, you should know when you have the same thing on the top and the bottom of a fraction, they're going to divide and give you 1. 5 divided by 5, invisible 1. 5 divided by 5, invisible 1. And what I have then is 4 5's left over. So the shortcut there is, if I have 6 on top and 2 on bottom, 2 from the bottom are going to cross off with 2 on the top. I got 4 left over. 6 minus 2 leaves me with that 4. Power of a quotient is again like the distributive property. You need to give that power to both the numerator and the denominator. So if I wrote this out the long way, 2 sevenths, 2 sevenths, 2 sevenths, 2 sevenths, 2 sevenths. I got 4 2 sevenths. Since I have 4 of those, that means I have 4 2's and I have 4 sevenths. So both the numerator and the denominator get the power. Next is negative exponents. So if you have a negative exponent, it's kind of related to this quotient property. It's almost like we have too many in the wrong spot. And what I mean with that is I don't have any a's in the numerator. That's why it's negative, because they're in the wrong spot. They're actually all in the denominator. So basically, whatever your exponent is, it switches. If it's in the numerator and it's a negative, it's supposed to be in the denominator. But if it's in the denominator and it's a negative, it means it's supposed to be in the numerator. And whenever you don't have a denominator, it's always got an invisible 1 underneath it. So I can flip this 1/4 because it's saying I have negative 3 4's in the numerator. It means I actually have 3 4's in the denominator. So I'm going to flip this one and then I'm going to give them each 4s. It's saying I don't have 4 2s in the numerator, I have 4 2s in the denominator. And I don't have 4 7s in the denominator, I have 4 7s in the numerator. So whenever you have a negative power, you flip it, and then the power turns positive. And the last one is again related, when I think of it, to that quotient property. So if I had 6 5s on top and 6 5s on bottom, if I get rid of all my 5s, I got nothing left, but you always have the invisible 1. So when you have 0 of something left, there's always that invisible 1 left over. Okay, a couple of examples. Rewrite without exponents. So if I have 6 to the negative 3, I'm going to use my negative exponent rule to rewrite that 1 over 6 to the positive 3. And then I'm going to use my calculator or my handy-dandy brain tool to know what 6 times 6 times 6 is. And that's it. Next one says negative 6 to the third. That's really the same as negative 6 times negative 6 times negative 6. And I just wanted to illustrate the difference between a negative in the exponent versus a negative coefficient. And the last one, 2/3 to the power of negative 2. First I'm going to flip it. And then I know 3 times 3 is 9, and 2 times 2 is 4. Example B, write in the form x to the n. So I want my variable to the power of a number. And if I see the same base here, my base stays the same, and all I have to do is add my exponents together to get my number up top. This is the rule where I want to subtract. My base stays my base. 11 take away 5 is 6. Remember, if I have 5 on the bottom, they're going to cross off with 5 on top, which means I have 6 left over. And if I have 6 x's and then 2 groups of 6 x's, that means I have 12 x's all together. And letter C is very similar to letter B, but we're going to add some coefficients in front of our variables. But we're going to treat these just like normal multiplication. I have a normal 5 times a normal 4, that's 20. I have 2 x's and I have 4 more x's, that means I have 6 x's all together. Normal division problem, I have a regular 12 divided by a regular 3, that means I have 12 divided by 3 is 4. And if I have 2 x's on bottom crossing off with 2 x's on top, that means I have 3 x's left over. 5 take away 2 is 3. The last one mixes together 3 or 4 of our rules. First we need to use our product rule here. We're going to make 2 to the third, and we're going to make x to the third. And then I'm going to distribute my 4 out, so this is going to be 3 to the fourth and x to the 2 to the fourth. So I can do 2 to the third, I know that's 8, and I can do 3 to the fourth, I know that's 81. So this is really similar to our first problem where I'm just regularly multiplying those numbers. And I think I can just do this here, 864, so that's 648 for my coefficients. Okay, I'm going to do my x's now. x3, I'm just going to keep it x3. X to the 2 to the 4, that's my power of a power rule. I need to multiply those together. And now I'm going to use my product rule to tell me to add the 3 and the 8 to get x is 11. Phew, that's a lot of stuff. You can always write these out the long way, the expanded way. I think that's a lot easier, but once you get the shortcuts down, then it's a lot faster. So your choice, expanded way, a little easier, write it all out the long way. Shortcut way, the rule way, a little faster, but takes a little more knowledge of your rules. Good luck on your exercises, and please let me know if you have any questions.